Hi, hello students, welcome back to our channel. This is Bhaskar Bora. We are discussing 5th chapter quadratic equation from 10th class mathematics. Now today let us see 8th problem from exercise 5.2. The 8th problem given as two trains leave a railway station at the same time. The first train travels towards west and the second train towards north. The first train travels 5 km per hour faster than the second train. If after 2 hours they are 50 km apart, find the average speed of each train. So here in this problem, if we read it carefully, we can understand that there are two trains and which are leaving a railway station at the same time. So both the trains are leaving the station at a time. And here the two trains are traveling in different directions. The first train is traveling towards west direction and the second train is traveling towards north direction. And next, the first train travels 5 km per hour faster than the second train. So that means here the relation between the speeds of the two trains is given. And how is that relation? Here the first train is 5 km per hour is faster than the second train. So here the speed of the first train is 5 km per hour more or faster than the second train. And after 2 hours, the two trains are 50 km apart. That means after the completion of 2 hours journey, the distance between the two trains is 50 kilometers. And using this information, we need to find the average speed of each train. So that means we have to find the speed of each train here. So to understand this problem clearly, let us visualize this problem. So here I am considering point A, which represents the railway station. So let us consider this point A as the railway station. And from this station, the two trains are traveling in two different directions. One is traveling in west direction. So I am representing the west direction with horizontal arrow mark line here. So this arrow mark line represents west direction. And the second train is traveling towards north direction. And so let us represent the north direction with another arrow mark line which is perpendicular to west direction. So this line represents north direction. So here point A is representing railway station. This arrow mark line shows west direction and this vertical arrow mark line shows north direction. Now let us take the two trains at railway station, that is at point A. So here these are the two trains that are starting from the railway station at the same time, and they traveled for 2 hours. After completion of 2 hours, let us assume their respective positions with the points B and C. So here B is the position of first train and C is the position of second train after completing the 2 hours journey. Now here in the problem, given that the distance between these two trains after the completion of 2 hours is given as 50 kilometers. Now in the picture, the distance between the two trains can be represented by joining the points B and C. So let us join B and C, which represents the distance between the two trains after completing the 2 hours of journey. How much it is given? It is given as 50 kilometers. Now again we have one more information, that is the relation between the speeds of these two trains. That is the speed of the first train is 5 km/h faster than the speed of the second train. So that means if we know the speed of the second train, then if we add 5 km/h to the speed of the second train, then we get the speed of the first train. So here if we assume the speed of any one of these trains, using that we can find the speed of the next train. So here the speed of the first train is 5 km/h faster than the second train. So let us assume the speed of the second train with a variable x. So let us assume the speed of the second train as x kilometer per hour. Now if the speed of the second train is x kilometers, then what is the speed of the first train? Very good. To get the speed of the first train, we have to add 5 kilometers per hour to the speed of the second train. Since the speed of the first train is 5 kilometers per hour faster than the speed of the second train. So therefore the speed of the first train will be x plus 5 kilometers per hour. So now we have the speed of the second train as x kilometers per hour and the speed of the first train is x plus 5 kilometers per hour. Now both these trains are travelled for 2 hours. In the 2 hours of journey with their respective speeds, they covered some distance. So here in this case, if you see the figure, here the first train which is travelled towards west direction, it is travelled some distance which is represented with AB. And the second train also is travelled the distance which is equals to length of AC. So now can we able to find these two distances that are covered by two trains? Yes, we can find, since we have their respective speeds and the required time to cover this distance. So let us calculate the distances that are covered by these two trains. So the distance covered by the first train in 2 hours. What is the distance formula? We know that when we have speed and time, the distance formula is speed into time. So here, by multiplying speed with time, we get the distance that is covered by the trains. So here, what is the formula for distance? Distance equals to speed into time. So here, what is the speed of the first train? The speed of the first train is x plus 5. So if we multiply the speed with the time, that is 2, we get the distance. We get the distance that is covered by the first train. So what we can write here, x plus 5 into 2, where x plus 5 is the speed of the first train and the 2 is the time that is taken by the first train. So by multiplying these two, we get 2x plus 10 kilometers. So 2x plus 10 kilometers is the distance that is covered by the first train, which is nothing but it is equals to length of side AB. And also let us calculate the distance that is covered by the second train in the same time, that is 2 hours. So what is the speed of the second train? It is x, and we multiply this speed with time, that is 2. So we get x into 2, which equals to 2x kilometers. Now here the distance that is covered by the first train is nothing but it is the length of AB in the figure. And the distance that is covered by the second train, which is equals to 2x kilometer, it is nothing but it is the length of AC. Now if we observe this figure, here we get a right angle triangle ABC, where length of BC equals to 50 kilometer and length of AB equals to 2x plus 10 kilometer and length of AC equals to 2x kilometer. So here, using these three sides, we can able to find the variable value, that is x. So for that, let us take this right angle triangle ABC, and we know that in a right angle triangle, the square of the hypotenuse is equals to sum of the squares of other two sides, which is nothing but Baudhayana theorem or Pythagoras theorem. Now here, according to the figure, what is the hypotenuse? It is BC. So here in the place of hypotenuse, we can write BC. So we get BC square equals to, so next we have side square. So here we can take AB as one of the side. So we get AB square plus, and the next side AC. So we get AC square. Now by substituting their respective values here, we get here BC equals to 50. So we get 50 square equals to AB equals to 2x plus 10. So we get 2x plus 10 whole square plus here AC equals to 2x we have. So we get 2x whole square. Now by simplifying this, here 50 square equals to we get 2500, which equals to, if we see here 2x plus 10 whole square, it is clearly in the form of a plus b whole square. And we know that a plus b whole square equals to a square plus b square plus 2ab. So here in the place of a we have 2x and in the place of b we have 10. So we can expand this as a square first. Here a square means 2x square, 2x whole square plus b square. Here b means 10. So we get 10 square, a square plus b square plus 2ab. That means 2 into 2x into 10. So a square plus b square plus 2ab. We expanded 2x plus 10 whole square using a plus b whole square formula. Now the last term, that is 2x whole square, write as it is. Now again simplifying this, on the left hand side we get 2500, which equals to 2x whole square can be written as 4x square plus 10 square is 100 plus here 2 into 2 4, 4 into 10 14, 40 into x 40x plus again 2x whole square can be written as 4x square. And here if we see these two like terms, that are 4x square and 4x square, have the same signs, that are positive. So we can add these two like terms. By adding them we get 8x square plus the next term write plus 40x, and next write the constant term, that is 100. Now transpose 2500 to right hand side. So by transposing this to right hand side, here on the left hand side we have 0, then which equals to 8x square plus 40x plus 100, and this 2500 will become minus 2500. Now again simplifying this, we get 8x square plus 40x, and here plus 100 minus 2500 will be equals to minus 2400, which equals to 0. Now here clearly in all the terms we have 8 as common. So by taking 8 as common out, we get x square plus 5x minus 300 inside the bracket, which equals to 0. Now transpose 8, which is multiplying here, to right hand side, so that we get x square plus 5x minus 300 equals to, here by transposing 8 to this side we get 0 by 8. 0 by 8 means 0, so we write 0. Now we get a quadratic equation, that is x square plus 5x minus 300 equals to 0. Now if we solve this quadratic equation, we can get the variable value, that is x. So to find x value, let us solve this equation. So how can we solve a quadratic equation? We have a method, that is factorization method. So let us factorize this quadratic equation using factorization method. So for that, what we have to do? To factorize this equation, first we need to split the middle term, that is 5x, as the sum of another two terms, such that the product of those two terms should be equals to x square coefficient and constant. So for that, let us first find out the product of x square coefficient and constant. So here, what is the x square coefficient? So clearly it is, we do not have any coefficient for x square here. That means we have 1 as x square coefficient. So we can write x square coefficient as 1 into constant. So here clearly we have constant as minus 300. So 1 into minus 300 will be equals to minus 300. Now we get the product as minus 300. So now what we have to do? We have to search a pair of factors for minus 300 such that sum of those two factors must be equals to x coefficient. That is here, what is x coefficient? 5. So now tell me, what are the suitable pair of factors for minus 300 we have to take here? whose sum is equals to x coefficient 5. Very good. Here we have to take the suitable pair of factors for minus 300 as 20 and minus 15. So using 20 and minus 15 we can split the middle term, that is plus 5x. So let us split it. We write x square. Plus 5x can be written as the sum of 20x and minus 15x. So plus 20x minus 15x, and the next term minus 300, which equals to 0. Now if you observe in the first two terms, it is clear that x is common. So let us take out x as common out. So by taking x as common out, we get x plus 20 inside the bracket. Now coming to the next two terms, here clearly minus 15 is common. So if we take out minus 15 as common, we get x plus 20 inside the bracket, which equals to 0. Now again, if we observe here, x plus 20 is common. So let us take out x plus 20 as common. By taking it as common out, we get x minus 15 inside the bracket. So now we have the product of x plus 20 and x minus 15 equals to 0. That means we can take x plus 20 equals to 0 or x minus 15 equals to 0. Now if we simplify this if we simplify these two, we get x equals to minus 20 or x equals to 15. And here we get the solutions of this quadratic equation as one is minus 20 and another one is plus 15. But here x, here what is x? We assumed it as the speed of the train, and we know that the speed of any object cannot be negative value. So here we cannot consider x value as minus 20. We can take x value as 15. So the speed of the second train is 15 km per hour. And the speed of the first train 5 km per hour more than the second train. So the speed of the first train will be 20 km per hour. So this is the solution for this problem. Now it is all enough for today. Let us meet in our next video with the next problem. Till then, bye. Thank you.